Welcome viewers. In this video we'll see the method of starting synchronous motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. What are the methods available to start the synchronous motor? We know that synchronous motor has no self-starting torque. Self-starting torque is not available, so we need to make some arrangement to start the motor. So the following are the methods employed. First method is using small DC motors. Second method using AC motor or pony motors. Third one using damper winding in the pole phases. And fourth one is running as a slip ring induction motor. So these are all the four methods available. Now we'll see this method one by one. So first method is the using small DC motors. So in this first method, small DC motor, the synchronous motor are coupled to the DC motors. With the help of DC motor, the synchronous motor is run at synchronous speed. So the DC motor is coupled. So while running the DC motor, the synchronous motor also run at the synchronous speed. The synchronous motor is excited by the DC source. So separately we are exciting the synchronous motor by DC source. Once the synchronous motor runs at synchronous speed, the DC machine acts as a DC generator and it is called as an exciter. So after getting the synchronous speed, the DC machine what we coupled earlier will act as a DC generator and it is nothing but an exciter. So the exciter provide DC supply to the field of synchronous motor. So the supply to the synchronous motor is provided by the DC supply. So this is the first method using small DC motor. First DC motor is coupled together and rotated at the synchronous speed and excitation is given through the DC source. Once the synchronous speed is attained, it acts as a DC generator. What the DC machine we couple and the excitation is given. And this exciter will provide the DC supply to the field of synchronous motor. So the synchronous motor will start rotate using these small DC motors. Now we'll go to the next method. So the second method is using AC motor or pony motors. A small direct coupled induction motor called a AC motor called the pony motor is used for starting the synchronous motor. So small direct coupled induction motor is also called as pony motor, that is used for starting the synchronous motor. The induction motor is capable of raising the speed of synchronous motor to synchronous speed. So this induction motor will be able to raise the synchronous motor speed to the synchronous speed. Once the motor attains synchronous speed, the DC excitation is given to the rotor. This is very similar to the previous method. After normal operation is established, the pony motor is sometimes uncoupled from the synchronous motor. So in the first method we use the small DC motor. Here we are using AC motor, that is small direct coupled induction motor called pony motor. Once the speed is attained, this is uncoupled from the synchronous motor. So the synchronous motor will rotate at synchronous speed. I will go to the third method. So the third method is using damper winding in the pole phases. The synchronous motor is made up of self-starting by providing a special winding on the rotor pole known as damper winding or squirrel cage winding or armature winding. So this special type of winding used in the rotor poles, right? Self-starting. In order to provide the self-starting, this damper winding is provided. The damper winding consists of short-circuited copper bar embedded in the face of the field poles. So the damper winding is nothing but copper bar, right? Not a coil, copper bar embedded in the face of field poles. When AC supply is given to the stator winding, and a rotating magnetic field will be produced. So which is cut by the stationary rotor pole. So EMF is induced in the rotor, due to which current flows in the damper winding. So this is nothing but a generator action. So due to the damper winding, this rotating magnetic field is produced, that is cut by the rotor pole. So EMF is induced in the rotor, due to that the current is flowing through the damper winding. Now we have a current carrying conductor, current carrying damper winding placed in the pole in a rotating magnetic field. So the rotor now we experience a force and start rotate. So that is we have a current carrying damper winding in a rotating magnetic field. Therefore, the rotor experience a force and start rotate. Synchronous motor is started as induction motor. When attain 95% of synchronous speed, the rotor winding is excited and the rotor is magnetically locked with RMF, rotating magnetic field of stator, and runs at synchronous speed. So in this method, due to the damper winding, it starts rotating. After 95%, excitation is given and it is run at the synchronous speed. Damper windings are short circuited. They draw high current at instant of starting. So star delta starter or auto transformer is used to start synchronous motor as a induction motor. So due to high current drawn by the damper winding, star delta starter or auto transformer is used. Now we'll go to the fourth method. Synchronous motor slip ring induction motor. As a slip ring induction motor, synchronous motor now act as a slip ring induction motor. Starting a synchronous motor as a squirrel cage induction motor does not provide high starting torque. So for achieving high starting torque, the synchronous motor is started as a slip ring induction motor. So during starting, we are acting as a slip ring induction motor. Now we'll see the diagram. So this is a diagram available. This is stator winding connected with three-phase supply. The rotor winding, the supply is given through this slip ring. This shaft available over which slip ring and brush is there. Through that we can give the supply. Here star delta connection is there. This star delta connection is available. So this side used for running. This is for starting purpose. Starting and running. During starting, the switch is placed here. After attaining some time, the switch is placed at the running side. So here the rheostat is available. And this is nothing but a star connected. This one end is connected together. Another end is available. It is at the maximum resistant position. Initially at the maximum resistant position. So the less amount of current will flow. Thereafter the resistance is keep on decreases. So the current will keep on increases. After attaining the synchronous speed, this switch is placed in the running side. Here the DC supply excitation is given. So the stator is connected directly. Rotor is connected through this shaft, slip ring and brush position. Here the two methods available, starting and running. During starting, we are having the set of rheostat at the maximum rheostat position. By reducing the resistance gradually, we can increase the current so that the synchronous motor will attain the synchronous speed. Thereafter, it is placed in the running side, that is DC supply. Now we'll see the description about this diagram. Here the damper winding is constructed as a three-phase star delta winding. They are connected in series to the external rheostat. External rheostat by means of slip ring, what we discussed in the diagram. So it is in the star delta winding connected through the external rheostat by means of slip ring. The rheostat are maintained at maximum position at the instant of starting. During starting, it is at maximum resistance position. Now the synchronous motor is started as a slip ring induction motor and hence provide high starting torque, right? So that the maximum resistance position during which it is started, so it will act as a slip ring induction motor and provides high starting torque. The resistance is gradually cut off as the motor gains the speed. So we are gradually reducing the resistance. When the motor attains 95% of synchronous speed, the DC excitation is given through the rotor winding, that is switch is placed in running side. Now magnetic locking is established between the stator and rotor and the motor runs at synchronous speed. Now the damper winding is short circuited by damper windings are shorted by short circuiting the slip rings. So the initially it is in starting position, that is rheostat at the maximum resistance, thereby resistance is gradually reduces, so the current keep on increases and motor attain the 95% of speed. After that it is placed in the running side, that is DC excitation is given, and finally these damper windings are shorted by means of slip ring, short circuited slip rings. So in this video we discussed starting method of the synchronous motor. Synchronous motor, we know that it's not self-starting, so we need to make a external arrangement to start the motor. Here we will discuss 4 different methods to start the synchronous motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.